Hello everyone, welcome to my YouTube channel Physics in a Nutshell. If you're just new to this channel, do subscribe to the video, and if you just like my way of teaching, hit that like button. Okay. By the way, in the last video, I just told you why to not skip the videos, right? I hope you have got it. By the way, the lesson we are basically discussing, right, is nothing but what? Human eye and a colorful world. It's not like the other lessons. Okay, in this lesson, we have to basically deals with what? Conceptual parts, right? In our last lesson, we have to discuss that light reflection and refraction. That is also conceptual too, but in that lesson, you have some problems too. But in this lesson, you are going to have more about concepts. Okay, if you just keep watching that video, what is going to happen? You are not going to get the concepts. Basically, again, we are going to discuss today lots of more conceptual parts relating to our universe or relating to our day-to-day life. Again, believe me, you're going to like the video. But you just don't have to skip it. You just watch the video properly and give me your what? 45 to 50 minutes. You're going to get 24 hours in a day. Just give me 50 minutes. Simple, right? So let's start the class. By the way, last class we actually discussed about the human eye. Right now, we actually discuss how actually human eye behaves. Right? What are the main parts of the human eye? Right now, so like cornea, iris, eyeball, pupil. Right? Lots of things are there. Right? Outer layer of the cornea. How the actually eye lens is able to reflect all the rays right now. So all these kinds of actually things we have discussed. Then we have actually discussed some defects that is actually present in the human eye, like myopia, hypermetropia, and after that, what is this presbyopia, right? And how we can actually correct. We also have discussed about that, like how to use lens in case of the myopia. What we actually use? We actually use one concave lens, right? In case of the hypermetropia, you use what? We use convex lens. With the use of that concave and convex lenses, we can actually cure them. Simple fact. Right now, today we have to discuss some extra terms, some new thing that is nothing but what? Refraction through prism. Okay, our today's topic is going to be what? Refraction through glass prism. Okay, this is our today's topic. We will discuss it today. But before discussing it, okay, when I was actually discussing about that lesson, that is nothing but what? Refraction of that lesson, last lesson, that is light reflection and refraction. In the refraction part, we have to discuss one thing, that is refraction through glass slab, right? That glass slab was what? Made of glass, and it is quite transparent one. We get that. In place of the glass slab, we get three special rays, okay? It was a glass slab, right? It was a normal, we get the first one incident ray, right? It get then refracted, and that refracted incident ray outer surface, it again get out of that surface, right? This is the incident ray, this is the refracted, and this is the what? Emergent ray. In this case, what you have actually got, that incident ray and the emergent ray is what? Parallel to each other, right or wrong? These two, if you just draw a dotted line, it will move parallelly to that, okay? But the thing is, that emergent ray was little bit got shift, right, from its original position. Okay, that's it, the fact. But now, today, we actually discuss about the refraction through prism. Okay, but let me erase this first. We just have to discuss about that refraction through prism. How a prism is able to refract one incident ray that is going to incident on it. By the way, first, before that, we have to actually understand the structure of a prism. If you just look through the front surface to a prism, that prism is going to look like this. Okay? If you just look from this surface, okay, or from the front side, and this is the main two-dimensional structure. But if you just try to look from the other side, okay, you are going to get a what? Three-dimensional view, and that view somewhat look like this. Okay, it's going to somewhat look like this one. Okay, somewhat look like this. If you just look this, what is going to happen? You are going to get what? Lots of surfaces. Give them A, B, C, D, E, and F. If you just clearly look that, you are going to get two triangular faces. That is nothing but what? Triangle A, B, C, and triangle what? E, F, D, or you can say D, E, F. Okay, it will be proper a little bit. Okay, D, E, F, and the triangle A, B, C are the two triangular faces. Again, if you clearly observe, you are going to get three rectangular faces. Okay, this one. Okay, this one. This is first reflecting or the triangular faces. That is A, B, E, F. First triangular faces. Again, on the opposite side, this one also. Okay, there is nothing but what? A, F, C, D, or A, C, D, F. A, C, D, F. And last one is nothing but what? The base one. This is the base, right, of the prism. Okay, there's nothing but what? BCDE, right? BCDE. These two are the what? Triangular faces of the prism, and these three are the what? Rectangular faces of the prism. Okay, simple fact. This is the main faces of the prism. But if you just clearly observe in this figure, what is actually going to happen? These rectangular faces, right? That is ABEF, ACDF, and BCDE is not that much parallel. But these triangular faces are parallel. When we have to discuss about the refraction through the prism, we only just have to refraction through these rectangular faces. Okay, that means we are going to observe this one. If we give them A, B, C, here AV face, BC face, and the what? AC face is one side or one part of the what? Or one side of the actually the rectangular faces. This one is the rectangular one side of the what? One face of the base rectangular, that is this one, and this AB is the rectangular face of this one, and AC is the rectangular face of that ACDF rectangular face. Clear? That means what we have to got, we have to actually observe the refraction through that what? Rectangular faces, right now, and that rectangular faces is not that much parallel to that like that of the what? Glass slab. In a glass slab, the opposite faces are what? Parallel to each other. But here, except that those actual triangular faces, all the rectangular faces are what? Not parallel. They are making some angle with each other. Okay, these are the angles that it is actually making. Okay, with each other. We got three rectangular surfaces and three rectangular surfaces making three angles with each other. And those angles are known as what? Prism angle or the angle of prism. Okay, these angles 1, 2, and 3. This 1, angle 2, angle 3 are known as what? Angle of what? Prism. Okay. If there is some question in your exam that what is actually angle of prism, you just have to say that the angle that all the rectangular surfaces making with each other is known as what? Angle of prism. Okay. This is the main structural surface or structure of the what? Prism is. Now we will check how the refraction actually occurs through prism. Okay. To understand the reflection through the prism, we just draw or just consider the front surface or the front look of the prism. Okay. Then what I am going to do, I will just draw two normals in each surface, that is AB and AC surface. I am going to draw two normals. Okay. And why normal? Because to have occurred as refraction, that we got the normal, right? This is the main basic law of one what? Reflection and refraction. Okay. These two are the normals of the prism right now. Now what I am going to do, we are going to do, or first we are going to get one incident ray. That incident ray will come here. This is one incident ray. See, when we are actually discussing about the refraction, we got that two main thing. Okay, when a light enters from optically rarer medium to optically denser medium, what actually happened? That the refracted ray moved towards the normal. Okay, again, when that ray comes from a denser medium to rarer medium, what is going to actually happen? That ray or that refracted ray going to move away from the what? Normal. Here, air medium, this is the glass medium right now, and say again air medium. That means this is a rarer medium, this is a denser medium, it is again a rarer medium right now. So that first incident ray is coming from what? Rarer medium, again it entering what? Denser medium. So what is going to happen? It will move what? Towards the normal. Right? Refracted ray incident on the what? This point, just give the 1 point, this is the 2 point. Okay, incident at the second point. Again, it is the conjunction of the two medium, right? Here it is the air medium, it is the glass medium. Again, here in this junction, it is the air medium, it is the glass medium. Reverse now, what is going to happen? It will move away from the what? Normal, since it is the rarer medium. And the incident ray was coming from, or the refracted ray was coming from what? For this refracted ray, this is the incident ray, and for this refracted ray, this is the incident ray. But we just name this ray as what? Immersion ray. This is the incident ray. Okay, I'm gonna give them some name P and give them name Q, R, S. Okay, this is the fact. Here what? PQ is the incident ray. Okay, and give the name angles I. This is the R, and this is the what? E. That is, I'm gonna say it. Okay, PQ is the incident ray. Then QR is what? Refracted ray. Right now. And what? This is about the RS. R is the what? Immersion ray. Okay, immersion ray. Okay. Again, we got some angles. Angle I is the what? Incident angle. Okay, incident angle. Angle R is the what? Refracted angle. Right? Angle E is what? emergent, or you can say angle of emergence. Okay, emergent angle, right? We have got it. And one more thing you have to write, that this is what? This is known as what? Angle of prism. That is angle A is known as what? As I told you that those rectangular surfaces make angle which is that angle is known as what? Angle of prism. Angle of prism, right? Again, if you just clearly observe, okay, what is actually going to happen if I first make a dotted line? Okay, and if for this emergent ray, if I just increase the line in the backside as dotted line, this line is going to meet here, right? And we are going to get one more angle. That angle is known as what? D. And that angle D is known as what? Angle of what? Deviation. Known as what? Angle of deviation. Now, you may think, what is angle of deviation is? Angle of deviation. First, you have to actually understand the deviation. Deviation means what? Deviation means how much it actually gets separated, or how much it actually moves from the original position, right? If I consider me as a moving in this path, okay, if there is some obstacle here, I have to move like that, na? That means what? I have to deviate myself from my original path. Again, I have to move back in my original path. This is the position where my actually path what? Get deviated, right? Because of that obstacle. So here it is the same thing. I am just actually explaining the meaning of the deviation, right? Now, what is the angle of deviation? Angle of deviation means how much is actually get deviated from its original path. Okay, with how much angle, okay, it get deviated from its original path. See, this was the incident ray. That means what? This was the path of the what? Incident ray or the original ray. Again, this is the what? Emergent ray. That means what you can say? This ray is actually giving us what? How much it get deviated. That means what you can say? Angle of D is nothing but what? Angle of deviation. So this is the whole thing about the angle of prism, or the refraction through glass prism. And using this refraction, we are going to get more thing, that is more upcoming things. Okay, you are going to get it. Just stay with me. Okay, we have actually discussed now how actually prism is able to refract all the rays, incoming rays, right now, making some angles, right, with the what? Incident ray. That means we have got the angle of deviation. Now actually you have to check some phenomena that we actually observe in our daily life. What? We observe the rainbow. Right? What is the rainbow is? We don't need to give anyone explanation about the rainbow. We all know rainbow. Rainbow is nothing but what? When you just get a pattern, in that pattern, if all the 7 colors are actually situated, that is the rainbow. But we have to just now wonder what is actually rainbow is and how rainbow is created. We have to just think about that. Okay. But before that, okay, we have to check how or when a white light, okay, or the white light of sun that is actually coming from sun is going to incident on the prism or one rectangular surface of the prism, how it is going to occur, or what is going to occur, how it is going to behave. Okay, you are just now observing in this figure, right? When a actually what ray is or white light is incident on that prism, as a refraction, what we are going to get? We are just getting 7 what? Patterns of ray, right, of different colors. Okay, we are just getting it, right? This is the main property of the prism, that it is now able to actually split one white ray into 7 different what? Colors. That 7 different color, okay, we are getting in a what? Some kind of band structure, right? We are getting all the colors in different bands. That bands are actually known as what? Spectrum. Okay, when we are just going to apply one white light on the surface of that prism, what is really happening? We are going to get 7 different colors of band. And all those 7 colors of band is known as what? Spectrum. Again, the phenomena of that prism or the procedure with that prism actually able to create 7 extra bands from one single light is known as dispersion. Okay, dispersion of the light that is created by the what? Prism. Okay, you have to just careful about that. We just have to know that. There may be a question, what is spectrum and what is the dispersion of light? If there is a question, what is the dispersion? You have to say that the ability of a prism, okay, to split one white light into 7 different colors of light, okay, that is known as what? Dispersion. Okay, now what is the spectrum? Once the dispersion created by the prism, we are going to get 7 different colors as a band. All those 7 colors band is known as what? Spectrum. Simple tag, we have got it. But if you just clearly observe that figure, what we are just noticing? We are first notice you can get that you are going to get 7 different colors, starting from violet to green, sorry, violet to red, right? That is PUBIL. That is violet, indigo, blue, green, yellow, orange and red. That is known as what? PIB0, right now? PIB0. Okay, 7 different color, right? So we are going to get 7 different color from a single white light. Okay, but what is the second actually information you are going to get from this, or the second observation you are going to get from this figure or from this image actually? What do you think? What is the second information or second observation you are going to get from that figure? Simple figure. You just clearly notice it. All the bands starting from the violet to red, they have some different amount of reflection angle or different amounts of deviation from the original part, right or wrong? Simply yes. Right now we are going to get 7 different reflection or 7 different angle of deviation from its original part, or bending angle, 7 different bending angle we are going to get from that single white light. Now what is actually that is happening? If you clearly notice that, you are going to observe that the red color is going to have what? Is having less amount of deviation from its original part, or least refraction compared to what? Violet. That is that violet light is having most, okay, on the highest amount of deviation or highest amount of refraction or highest amount of bending after it get refracted, right? We have to actually understand it. See, you will better understand it once you go to the higher secondary level, when you have to discuss about the properties of the light in brief manner. But in class 10, it is not in that brief manner, but still I will explain you. It's because of the first thing is going to be intensity. Okay, that the red color is having high amount of intensity compared to the blue light or compared to the other light, and because that the red light is having high amount of or large wavelength or longer wavelength. Okay, those rays having longer wavelength, okay, they are going to have high amount of intensity and they are going to have least deviation. Okay, you are going to get one fact in the later part of this video, that why actually sky blue look blue in the noon time or in afternoon time and in the evening time. Okay, when the sun is about to set, on the early morning time, when the actually sun is about to wake up or about to rise, you look the sky and you're going to observe some yellow orange mixed color, right? That means you can say simply reddish color. Okay, you're going to get it. Why? Because of that deviation by the what? Of that white light. Okay, I just explain you, don't worry about that. Okay, so this is the reason why you are going to get actually 7 different color in some different positions, or in, it's not like that after violet you're going to get green, or after green you're going to get yellow. Not like that. They are not mixed color. They are always arranged in a certain band structure. Okay, it is how that nature is beautiful, right? They arrange them in a proper manner. So it's our duty now as a human being. We are now intelligent enough, right? We are the most among intelligent creatures in this whole universe, right? In the not only whole universe, in this world, not in art, right? Only in art we are just the most intelligent person. Okay, so as an intelligent person, we have also a responsibility to discipline ourselves, to make a discipline, to bring some kind of discipline in our life. So it is your responsibility to bring discipline. So watch the video properly. Okay, this is also some amount of discipline that in your life. If you watch the video properly, we are going to get to learn some new things today. Okay, that you actually observe in your day-to-day life. Just be with me for this rest of the 20 to 30 minutes. Okay, you actually understand now how the prism is actually able to split all the incoming white light into 7 different color. Okay, that is known as spectrum, and that whole process is known as dispersion of white light. Now, one great scientist, you have actually heard that name. That is nothing but the great scientist or the great physicist or the revolutionary scientist known as Sir Isaac Newton. Okay, he first did one experiment. Okay, that first experiment was this spectrum deviation or the dispersion of the white light into some spectrums was first experienced by or experimented by Sir Isaac Newton. Okay, in the first figure, you are just noticing that all the white light is going to disperse in 7 different colors, right? Then Sir Isaac Newton did one experiment. He just placed one prism, okay, in a single position, in a single manner, that it is the first one is situated. He then observed that nothing is actually changing. Okay, he observed that, okay, from the first prism I am going to get 7 different colors. Okay, then what is going to happen, okay, if I expose one more surface of the prism to all those 7 different spectrum? Okay, these are the nature of the great scientists. They always like to experiment. Okay, they always like to experiment. They are not like us. Okay, so we have to learn lots of things from them. What Newton did, he placed one more prism to those all incoming or the outgoing 7 different colors, but he placed in the same manner that first one is actually placed, but he didn't get anything. Then he used one of his trick. He then just revert that that prism. Okay, then he get that all those spectrum that is going to enter the second prism, when they will come out of the second prism, they are going to get only that single white light. Okay, that means what you can say, if this is the first prism, okay, and he plays the second prism like that, na? You get it? So this is the incident ray, okay. So if I consider that all the incoming rays are going to move like that, okay, this all the what? Why these three lines are the spectrums of the, consider that these three are the spectrum of the single white light. Once it get incident with the second prism, which is actually placed like that, okay, inversely placed, as the immersion ray, they are going to get the second one single ray, okay, one single ray they are going to get. So this is the incident ray, these are the what? Refracted ray, these are again the refracted ray, this is the what? Immersion ray. If you just clearly observe what we are actually observing, that all three spectrums was originated from the single light, okay. When the second prism is placed, all the three spectrums are going to give the same white light. That means they are originating the same origin. Okay, that means what you can say, they are originating the same origin. That is where it is coming from. So from this experiment, what can you actually conclude? Think it. What actually you can conclude? You can simply conclude that our white light that is actually coming from what? Sun is basically consist of what? 7 different colors. Right or wrong? If you are just able to split all the incoming rays in 7 different color, again, if you are again become able to coincide, okay, all those 7 color into one single light, you can actually conclude that, right? Our white color that is actually coming from sun is basically consist of what? 7 different color. Okay, this is what actually we can conclude from this experiment. Okay, and that is the reason, okay, why we are going to get the rainbow. Now what actually happens in the rainbow? Okay, we are actually always able to observe that rainbow after a rain. Okay, and you are going to always observe the rainbow in the opposite side of the sun. Okay, once there is a rain, what is going to happen after the end of the rain? What is going to actually happen? Or sometime actually when there is little bunda bandi, okay, of the rain, again in that moment you are going to observe the what? Rainbow. But to occur the rainbow, there should be a proper sunny rays. Okay, what is going to happen when there is some kind of rains in the Earth atmosphere? Some water droplets actually are there. Okay, and those water droplets behave as a what? Prism. Okay, and from the concept of the prism, what we have actually learned that using that prism and through that prism we are going to get what? Splitting of the colors. If that water droplets, okay, behave as a prism, it is again going to give us what? Some splitting of the rays too. But here something little different phenomenon actually occurs. Okay, if it is a water droplet, okay, na, that is actually having in the Earth atmosphere, what is actually going to happen? If it is one incident ray that is actually coming from the sunlight, at this surface what is going to happen? It is going to get what? Reflected, right now. So in case of prism, what actually happens? If it is the prism, it is an incident ray, it again get reflected, again after that it will again pass out from the second surface, that is it becomes the immersion ray. But in this case it is not actually happened. Here what actually happen? It gets reflected inside. Okay, it gets reflected, and that reflected ray again get refraction, okay, and comes out as a 2 ray. Okay, comes out as a 2 ray. And that 2 ray is going to fall, not only 2 ray, lots of, I am just again saying that 2 ray, I am just showing as a 2 ray, but not also 2 ray, 7 different colors is going to come in your eye. Okay, then you will be able to see the that rainbow. Okay, maybe you think that there may be some kind of screens are there, all those reflections. See, in case of prism, what is going to happen? If you place a screen, then you are going to get the what? Spectrums of the 7 colors. Okay, but in case of the rainbow occurring process, all the rays have to come in your eye, then you will be able to see the what? Simply what? Rainbow. That means the rays are coming, all the 7 rays are coming in your eye, that you are going to get the image of the 7 rays in differently, then you are going to get what? Image of the what? Rainbow. That's how actually rainbow occurs. The main fact, right? That rainbow occurring of the rainbow. Till now, you are just watching the rainbow. If now, maybe tomorrow, the day after tomorrow, if their rainbow is occur, you can explain everyone that how the rainbow actually occurs. You just have to explain that after the rain, okay, and that rainbow have to always occur on the opposite surface of the what? Sun. That means if the sun is here, rainbow have to occur in this surface. Cannot occur in the same side of the what? Sun, because the ray have to fall on that water droplets, na? That's why all the rainbow occurs in the opposite surface of the what? Or opposite side of the sun. Okay, after the rain stop, the water droplets are present in the what? Air molecule. Okay, and those air molecules or those water droplets behave as what? Prism. In case of the prism, we are going to get what? 7 ray spectrum, right? So similar case will happen in this water droplet too, right? This water droplet, what actually happens? The ray first incident, and after that incident, the ray get refracted. And that refracted ray again get reflection in the inside surface of the or the inner surface of the water droplet. Again that the reflected ray again get refracted by the second surface, right? All those refract after that refraction, what we are going to get? We are going to get the what? All those 7 colors, and we are going to get the image as a rainbow. Simple fact, okay? It's not a hard thing to actually understand. We got it now. How actually a prism is able to refract the rays, then using that phenomena, we actually understand the concept of the what? Dispersion of the white light using that prism, and using that concept, we actually able to learn what? How actually rainbow occurs, okay? How there is some rainbow we always get after the rain in the opposite side of the sun. We get it. By the way, from the rain concept, actually I got in mind that it is completely raining outside, okay? Heavily raining. So if you somehow get some kind of sounds of the rain, please don't mind, okay? And in this, do you know what? In this rainy season, we always get a mood to have some kind of garam chai, garam pakoras, right now. So yeah. Oh, by the way, yes, from the concept of that garam chai and garam pakora, I've got in mind that whenever you make tea, okay, you have to boil your water to 100 degrees Celsius, and it starts boiling. Okay, what will happen in that 100 degrees Celsius temp of temperature? That upper surface of the liquid becomes what? What? That means what? Water still starts vaporizing. So and then vapor make the air what? Hot. Similar thing is actually going to observe when you in the winter season you do bonfiring, right? To make yourself warm. So during that firing, what is actually going to happen? The upper surface of the fire is going to be what? Hot, na? So whenever you try to observe something through that hot air, what is going to happen? What you actually observe? Have you ever noticed that image will, what looks like flickering? It's like that, na? It's just shaking or shaky image you just actually got. Do you know? Have you ever wondered why actually this happened? It's because of one single phenomenon that is known as what? Atmospheric refraction. This is the main reason. This is the main reason. This is the atmospheric refraction is the main reason to which we are going to get lots of things now. Okay, lots of phenomena we are going to discuss based on this atmospheric refraction. Okay, we are going to discuss step by step. Okay, by the way, first, just understand what actually happens when you just try to look something through a hot air. Okay, above that fire. Okay, when there is fire in your wood, or you do bonfiring, or you do some boil some amount of water to 100 degrees Celsius, what actually happens? The upper part of that liquid or upper part of that fire becomes hot. Once it becomes hot, that outer or the air molecule that is actually just above that fire or that hot water is going to get less dense. Okay, and we know when a object's ray comes through that rare to denser medium or denser to rarer medium, what is going to happen? It is going to be what? Refraction, moving away or towards the normal. In this case, if that air becomes what? Less dense, okay, what is going to happen? It will move towards the, move away from the what? Normal, right? So that means what? Simply if you understand, there is refraction. Okay, refraction of in where? Atmosphere, right? That's what is known as what? Atmospheric refraction. When there is atmospheric refraction, we're going to get what? Image formation. But the thing is that air, once it become hot, it becomes what? Unstable. So you are not going to get a proper stable image. So that's why you should observe that flickering image. Okay, you're not going to get a single image or stable image. That is the main reason, or that is the fact of the atmospheric refraction with which you are going to get a flickering image. And once you are just discussing about the flickering image, can you give me one example of that flickering image that you actually observe in the night season or night time? That's what? Flickering of the what? Star. But our English literature give a beautiful name to that flickering of the star. It's known as twinkling. We actually heard now, twinkle, twinkle, little star, how I wonder what you were. Okay. Now we will discuss how wonder it is. Okay. How wonderfully it actually flickers. We have to now understand it. But after today's class, you don't have to say that how wonder what you were. Okay. We'll understand that. Okay. Now just look in this figure. What you are just actually observing? You are observing that the rays which is really coming from that what? Star getting deviated. That means what you can say, whenever a ray actually come from star, it have to come through lots of atmospheric conditions. Okay. Outside Earth, there is no situations like that. Okay. But when it enters the surface of our Earth, okay, outer atmospheric surface, okay, I'm just, when it actually enters the outer atmospheric condition of our Earth, what is really going to happen? It have to actually face lots of some atmospheric conditions, like dust particles are there, lots of gas molecules are there, right? Lots of actually clouds are there, lots of things will be there, okay, with which they have to actually face. But before that, we have to actually understand one basic thing, that the star, okay, looks like that a very tiny particle, but it's not that a tiny particle. It looks tiny because, or look point size because it's miles away, not actually miles. We can't use that word miles. What I'm actually saying, man, it actually light of years away, million times of light years it's actually away from us. Okay, when an object look very much away from us, what we actually look, it always looks like it is small in size because it is like angular vision is also there. Okay, it is some different factor is there. Okay, but simply if you know that when an object is quite distant away from us, it always looks like point size. Right now, so that beam of the light will become what? Also point size, also what? Thin light. Okay. So when a thin light comes into our Earth or enters our Earth's atmosphere, what is going to happen? It will be easily deviated by the what? Our atmosphere, or the dust particles or the gas molecules are there in the Earth's atmosphere going to what? Deviated it from its original position. Right. Again, sometime or in some portion of the Earth atmosphere, in some portion it is the dense particles or their densities may be high, in some portion the densities become low. Once you come very much downside, what is going to happen? The particles will be what? Less or high amount of density. You're going to get high amount density. That's why that ray that is actually coming from actually star, that ray will move towards the normal, because in the lower portion of the Earth or Earth surface, density become high. Okay, and the upper surface of that atmosphere, the density is less. Okay, that means what you can say, the lower surface of the Earth atmosphere is what? Denser medium, and the upper surface of that atmosphere is what? Rarer medium, right? So once a ray enters from rare to denser medium, what is going to happen? That ray or the refracted ray going to move towards the normal. So if you just clearly observe this figure, you are going to get the apparent position. Okay, now what is the apparent meaning of apparent? Apparent means, okay, which is actually false but actually exists. Okay, exists but false position, right? That position we are going to get, it is not it's a real position. Real position is downward position, right now. So that's the fact. Okay, due to that atmospheric refraction in the atmosphere, we get the image positions, okay, in a different position. That is not an apparent position. But the thing is that change of position and that flickering of the star occurs continuously, okay, in a very part of a second. That means if you make lots of part of 1 second, if you consider one part of that second, so that means what you can say how quick it is. Okay, it continuously is flickering. See, if you just clearly notice that my hand is now flickering right now. Okay, it is not happening continuously in every second, maybe in two times in 1 second, right? And you are not going to get my what stable image. So in case of the star, we are not going to get a stable image. But if you just move our Earth surface or outer surface, or maybe in space, you are not going to get the flickering image of the star, because why? There is no atmospheric conditions are there, no dust particles are there right now to actually deviate that ray. So once you go to space, you are not going to get that flickering of the star. Okay, that is the main reason why that actually star flickers. We have actually understood the concept of the flickering of the star, but what about the planets? Do they really flicker? No. Now what is the reason behind that? See, the main reason is nothing but what? That distance. Okay, I told you that those stars, okay, are quite thousands of millions of light years away from us. Okay, and those planets are also lots of distance away from us, but compared to that distance of the star is not that much distance away from us. Okay, that means quite nearer to us right now. This is the main reason. So that beam will be thicker compared to that of the the beam of the light that is actually coming from what? Star. One reason. Again, when actually, just let me draw first, that Earth actually or any kind of planet looks like some flat disk. Okay, some look like flat disks when actually observed through a telescope. Okay, so what actually happens? At every point on the edge of the actually that flat surface or flat disk. Okay, consider lots of points are there, right? Lots of points are there in the edges. Okay, so the ray that is coming from here, okay, and coming from the opposite point of the ray, what is actually going to happen? The two rays are going to be cancelled out each other. Okay, similarly, if one ray comes from this point and another ray comes from this point, that means these 2 points are opposite to each other. So again, some ray comes from this point and other ray comes from this point. After refraction, they are going to cancel out the effect of refraction each other. Okay, so what we are going to get? We are going to get the net deviation as 0. So we do not get the flickering image of the planet. That means what you can say, that as like the stars twinkling, there is no twinkling of the planet because of the cancel out of the refraction part or the deviation part. They actually cancel out the deviation of each other. Okay, when we have to actually observe that planet through naked eye or through telescope, so we do not observe that kind of flickering of the actually what planets. Now we have to discuss one more interesting topic. That topic is nothing but what? Rising and the setting of a sun. Okay, by the way, do you know one thing, that whenever a light comes from sun, how long it takes to come from the sun to reach our earth? There is almost 8 minutes late. That means the time when you are getting a ray of sunlight, you are almost 8 minutes late. Okay, now here what is actually observing is some kind of fact. Whenever you just look sun rising and setting, you are almost 2 minutes late. Okay, how it is really occur? See, whenever there is a sun which is really going to set in the east, that position is known as what? That position is known as horizon. Okay, horizon. And now what is horizon? Horizon is nothing but, if you consider this as an earth, okay, if you are just standing here right now, this position is known as the horizon. Consider this as a sky position and this is a ground position, right? It is looking like that the sky is actually meeting here right now in the ground. That position or that direction or that actually alignment is known as a horizon. Okay, so when the sun is about to set, okay, it is actually in the horizon position, and in the horizon position the atmospheric refraction becomes high because at the horizon level, okay, the air layer becomes more thick right now. So that means what? Air's density is going to be high, so the refraction is going to be what? High. So what actually happens? So when the ray is actually coming from a sun which is actually the horizon position, the ray is getting refracted, right, to reach this observer right now. So if I draw a dotted line to make the proper ray diagram of the diffraction, what is going to get? We are going to get a one apparent position of that sun. Okay, that apparent position is going to give me that image right now, and that image, okay, we are going to get 2 minutes after. Okay, that means once the sun is going to set, okay, after that we are going to observe that. That means when that sun is about to set, it is going to be here. Okay, once it gets set, that means once it reach here, okay, after the setting of that sun, then the apparent position will be here. That means we are just 2 minutes later. Okay, we are going to just 2 minutes late or 2 minutes lately we are going to observe the sun setting. Okay, but in case of the sunrise, it's almost reverse. We are going to get the image of the sun, okay, before it actually rises. That means we are going to get 2 minutes early, okay, in the rising of the sun. So this is the fact about the 2 minutes early and 2 minutes late of the sunrise and the what? Sunset. It is all because of the atmospheric refraction. All because of the refraction that we are going to get the 2 minutes early and 2 minutes late of that refraction. Simple fact, na? Do I need to explain again? Simply, if you need to understand, if it is the actual position of the sun, okay, and it is a horizon level, in the horizon what actually happens, the atmospheric refraction becomes high. So in that case, what actually happen? After lots of refraction, it actually reaches the observer's eye. But if you draw a dotted line, okay, to actually understand, to actually show them properly, you are going to get one apparent position. That apparent position is quite visible to us, not that actual position. Okay, we always observe that apparent position. That's why we have to say that we actually observe the sun setting after 2 minutes of the actual setting. That means when the sun is actually in this position, that is actually setting, we are actually observing a sun is setting, then the sun will be here. That means it will move 2 minutes early from that actual setting position. Again, in case of the sunrise, what is actually going to happen? Before the sun actually rises, we are going to get it, because in that case we are going to get the apparent position in a little bit upward, right now. So that actually happens in case of the sunrise and the sunset. In case of sunrise, we are going to get the image 2 minutes early, but in case of the sun setting, we are going to get the image 2 minutes after the actual sunset. So this is the concept about the what? 2 minutes early and 2 minutes later of that sunrise and the sunset. Our next topic is going to be scattering of light. Okay, what actually mean by scattering of light? Maybe in class 9 you will get it. What do you think? What is the scattering of light? Scattering of light means when a light enters through or passes through a certain medium where lots of particles are there of the same size of the wavelength of the light. Okay, it actually deviated from the original position. Okay, that is basically known as what? The scattering of light. What actually happens during the scattering of light? Okay, before that we should actually study one thing, that is nothing but what? Colloidal solution. In class 9 you actually get it, colloidal solution, like homogeneous solution, heterogeneous solutions, like that, no? You get it, homogeneous and heterogeneous solution. When we actually consider a homogeneous solution, what actually happens? There is nothing to actually deviate that actually beam which is actually passing through a homogeneous solution. Okay, so in homogeneous solution we are not going to get any scattering. If there is no scattering, we are not going to get any we are not going to be able to see anything which is actually present in the solution. That is the main difference of the homogeneous and heterogeneous solution. In case of the heterogeneous solution, or in case of the heterogeneous mixer, what actually happens? The particles are actually suspended or actually moving around here and there, right? In the case of the heterogeneous mixer, like milk. Milk is a what? Though the mixer looks like homogeneous, but it is actually a heterogeneous mixer. So whenever you just pass a light through that milk, what is going to happen? You are going to observe what is actually present in the milk. That is known as what? Tyndall effect. Okay, in nature or in our environment, also Tyndall effect also occurs. Okay, that means in our atmosphere, when light comes from certain position to another position, you are going to get observe Tyndall effect. Okay, see, consider a room. Just consider a room. Okay, this is also a room, na? If I make a hole in that room and if I make the room smoky and dusty, okay, if the sunlight comes from that actually hole, okay, what we are going to observe we are going to able to observe the light or the ray of that light distinctly. It's because inside the room there is also smoke and dust particles are there. That means what? There may be some what? Particles are there to actually deviate it or to scatter it, right? This is the main scattering phenomena or the main scattering principle. If on the way there are some particles are there, and that particle is able or large enough to scatter the white light or the light actually coming from the sun or coming from a source of light, this one is the scattering of light. Okay, this is what we are going to get the scattering, and due to that scatter we get the what? Tyndall effect. We get it now. Once you just make a hole in your room, okay, so in some kind of wooden wall or some that walls actually made up of what? Bamboo, holes actually still present. So through that holes, if you just clearly observe if that some kind of actually what smoke and some dust particles actually present in that hole, you just clearly noticing here, you will be just able to observe that. Okay, that like that thing you are going to get the what? Tyndall effect. And that Tyndall effect is really because of what? Those dust particles or those smoke that is actually present, and that smoke and that dust particles actually able to that deviate that actually what? Or actually scatter that incoming incident light. Clear now? And why it is able to scatter that light? Because we know that light is what? We have some kind of wavelength. Okay, if that particle which is actually going to scatter that light is of the same size or that large enough to scatter that light, then the scattering of the light is going to occur in that position or in that surface. Okay, that's how maybe Tyndall, that's how actually Tyndall effect occurs. We have actually now understood the concept of what? Scattering of light, right now. So what basically happens in case of the scattering of light? That incident light is going to be scattered by what? That moisture and that what? Dust particle present in the atmosphere. Again, you can also observe if you just move through a what? Dense forest. Okay, if maybe in the winter season, if you try to travel through those kind of dense forests, we are going to get the same amount of Tyndall effect. Okay, that ray that is actually coming between the trees, you are going to get the actual, or you will be able to observe that path of light. It is because in the winter season, what actually happens? Water droplets are actually present in the atmosphere. Okay, they become able to scatter that ray that is really coming from that source. That's how we will be able to observe the path of light that is actually coming through that forest simply. So that is known as the what? Tyndall effect. Now, using that scattering of light concept, okay, scattering of the that is actually light actually coming from some source or coming from that sunlight. Okay, you can actually discuss some concepts that you actually regularly observe in our daily life. One concept is nothing but what? Blue sky. Right now, blue sky that we actually observe when the sky is actually free. Right? We actually observe in the what? We observe the blue sky only in the what? Afternoon time, not in the evening time. We can get it. Why this actually happens? See, that scattering factor will only occur if there is some particle which is actually able to actually scatter the wavelength of the light. Okay, so what actually happens? The particle that is actually present in the atmosphere is not that much big enough to scatter the visible light. Right now, if you consider that a visible light consists nothing inside it, you're going to get that visible light wavelength is so much big that particle that is actually present in the atmosphere is not that much able to scatter that visible light. So you're going to get nothing. But we know that visible light consists of what? 7 different color. Okay, and that 7 different color is going to have 7 different wavelengths. Okay, the longer wavelength is going to have of that red color. That means red color is having high amount of the larger wavelength. Okay, the shortest wavelength is going to be what? Of that visible light. Not sorry, visible light. The shortest wavelength is going to be of that of the what? Violet color. That means from violet to red, wavelength actually increases gradually. Okay, so at the daytime, what actually happens that mainly that blue light is actually scattered by the particle that is actually present. So what actually happens? Why you do not get the red color? You maybe have some questions. So why in the afternoon time we only get the blue color, not the red color? Because I told you that the red color is having larger wavelength, and that large wavelength is not deviated by or is scattered by the particles, because that particle is not enough big to scatter that red light, because it is quite large enough. So let me actually explain what actually happens. Consider this is the red color and this is the blue color. Okay, the red color having a wavelength like that. Okay, and the blue color having a wavelength like that. Okay, if I consider a particle of the same size here and here, so tell me one thing, in which case the particle will be able to scatter the light? Obviously in this case, here the wavelength is able, or that particle should be able to scatter that wavelength. Okay, simply if you want to say that particles will be of the size of that wavelength, then it is become able to what? Scatter the blue light. But in case of the red light, the wavelength is quite big. So that light will pass, that red light will pass without undeviated, without getting scattering. Okay, that particles will be here. Right now, that particle is not that much able to scatter that light in the afternoon time only. Okay, so in the afternoon time, only the blue light scattered by the what? Particles. That's why we actually observe that sky as blue one. But the interesting fact is, if you're just observing that blue sky, you may think that okay, when we will move outer space, we are going to get the same blue image. But if you move outer space, what is going to be there? You just observe the sky as what? Dark one. Now, what is the fact behind that? Because we observe that, we understand that if there is some particles present in the atmosphere, that particles leads to what? Scattering of that light. If there is some kind of scattering of light, we are only going to get that color of that scattering. Right? If there is no particles or no source to scatter the light, we are going to get what? No image. That means if there is no image means what? Dark image. Right? That's why in the outer space, we are going to actually observe the sky as what? Dark one. Because there is no source, no thing to actually disperse or to scatter the light. The scattering will occur only if the density of the particles are high. Okay? Not only one particle is going to scatter the whole light. Do keep it in your mind. Only one. I am just showing here only one particle. That is, there will be billions of. You just actually can't count them. Lots of particles are there in the sky. As a whole, they are able to actually scatter the light. Then you are going to get the what? Scattering of the light. If in the afternoon we are going to get the blue as the sky. Okay. But in the evening time, what is really going to happen? In the evening time, as I told you, the actually sun is in the horizon level. Okay. So in the horizon level, when the sun is, what I actually told you, that in the horizon level, atmospheric refraction is high. First one. Again, in the horizon level, what actually happen? The density of the molecules becomes high. Okay. So the light have to travel a high amount of distance. Okay. When it is in horizon level. So that shorter wavelength, okay, is not that much able to move a larger amount of distance. See, I have drawn two peaks, but with the two peaks it has traveled this much of distance, right? Even I have drawn 1, 2, 3, 4 peaks. With that 4 peaks, it only have traveled this much of distance. So tell me one thing, which light is going to travel high amount of distance, red or blue? Obviously red one. That means right now, if I make a small steps like that, okay, right now, again if I make large steps like that, so what is actually going to happen? With my large steps, I am going to travel lots of distance. So consider these peaks as steps. Okay? Right now? So with that, this much of big steps, red light is going to travel high amount of distance compared to the blue one. So when the sun is actually in the horizon level compared to that earth, that blue light is not going to be able to move that much of distance. So what becomes the dominant color? The red one. Not only the red one, you are going to get a mixture of the yellow, orange and red, because we get the what? Fifth here, right? From here, that is from yellow, wavelength starts increasing. Okay, here again from green portion, wavelength starts decreasing. That means that violet color is going to have lowest amount of wavelength. Okay, if it is the blue, if it is the violet is going to have this much of wavelength. Okay, violet color will look like that. So the violet color will stop here. See, here I have drawn 1, 2, 3, 4, 5 and 6 peaks. Okay, so this has to be only this much of distance compared to blue. Again, it is also shorter than the blue one. Okay, that's what we can say in the evening time, right? The red one will be the dominant color or dominant ray that is going to move towards our eye with a high amount of big wavelength. But in this case, you just have to consider the scattering. Now, how it is actually occurs scattering? In the evening time, that ray have to come from the horizon level. If it is the earth right now, it is the earth. If you are standing here, it is the sun. There are lots of buildings are there right now. Lots of buildings are there. Lots of trees are there right now. So the rays have to pass through all these buildings, trees. Lots of monuments are there. Right? Lots of big houses. Lots of big towers are there. So what is going to happen? Those big particles, big buildings are going to act as a particle. Now those particles, those buildings will be able to scatter that red light. Clear? So then the red color will be scattered to our eyes, and we are going to observe our evening sky as what? Red one, or a mixture of red, yellow and orange. So this is the main reason why you actually observe in the afternoon time sky as blue one, or in the evening time you observe the sky as red, blue and yellow mixture. That means that some kind of orange and red color. This is the main reason. Okay, and that's how actually refraction hour ended here. Okay, refraction thing actually occurred here and ended here. Okay. See, in the very first lesson of the light lesson, we actually discussed how light behave. Like now, then we have to discuss about the reflection, then we discuss about the refraction. As I told you, where we will actually end that lesson, it is going to start from that part. We have ended that lesson in the refraction part. Okay, and from the end of that refraction, now we get that the second lesson, it is nothing but what? Human and the colorful word starts from there. Right now, so here actually officially with the use of that refraction and the reflection part, this lesson ended. Okay, so with the help of the refraction and the reflection, we have actually discussed lots of things, right? Starting from rainbow to the color of the sky, from blue to red. Quite simple one, quite interesting one actually. So that's why I am telling you that if you have here with skipping the video, just please rewind the video and watch the video again. Okay. If you just skip the video, you will miss lots of important things to actually in your life. Okay, from today, okay, you will be able to understand, or you will be able to actually explain anyone or everyone that why the actually evening sky looks actually what? Red one, and why in the afternoon time if the sky is free, okay, and clear, it looks like what? Blue one. But you may ask there, sir, why in the actually in the sea level we just actually color as a blue? It doesn't like that. Our just those waters actually reflect the color of the sky. Okay, simple fact. If in the evening time, if you just clearly notice, our river looks like what? Red is color, water is having no its own inner color. Okay, so it just reflects the color of the sky. Simply is that. Okay, that's why you just look the color of the water as blue one. Okay, simple fact is this that. Okay, that's why actually not actually mentioned that. It's just smart enough to actually understand this. Okay, so these are the facts of this lesson, and our this lesson is actually ended here. So by the way, again I have to mention some winner's name. Okay, I have actually asked some questions about that last quiz, right? So we'll move towards that right now. So I hope you have watched the whole video. Okay, I hope you have liked the video. But if anyhow, okay, if there is any kind of mistake, or if there is something wrong thing that I actually said or explained, it's your now responsibility to explain, correct me. Okay, you have some comments in my YouTube section, just tell me, okay, sir, this thing you actually missaid, or you just saying something wrong, then I will still correct it. Don't worry about it. See, I'm also a human being, na? So there is a 100% possibility that I'm gonna make mistakes. Okay, so you just feel free to tell me. Okay, don't hesitate to tell me. Okay, you just tell me. By the way, if you just like my way of explaining, please just hit the like button and just subscribe to this channel if you have not done yet. Do it, and I'll be more happy. By the way, this was our last quiz question. Okay, this question asks that when object moves closer to the convex lens, the image formed by it shifts, and the options are away from the lens, then shifts towards the lens, then shift first towards and then away from the lens, and first away then towards the lens. Okay, then you have to give answer with proper reason. Okay, we will check that what is going to be the answer first. Okay, just look here. In the first case, the object was placed at infinity, then the object forms at where? At focus, right now. Then when the object placed between infinity and twice of f1, then image formed between f2, or that is focus and radius of curvature, right? Here this one, that means what? Image is actually moving from its focal or from the focus. That means from its original position it is actually moving towards the right. Okay, when the object placed in at where? Center of curvature, again image formed that center of curvature. Okay, image again move toward center of curvature. Then when the image is actually formed between focus and the center of curvature here, again the image move away from the what? Lens, right? Again, when the actually image placed in object placed at between focus, image formed at infinity, that means further away from what? Center of curvature. Okay, these fives are the main position where the actually image is going to be formed for the real image. There is only one condition where the actually that convex mirror is going to form the what? Very partial images. Okay, but we have to only consider the real image, because we always consider, though there is only one condition which is actually giving us the what? Partial image, we always have to consider for our convenience, okay, that convex mirror always form the real and inverted image, not the partial image. It is a special condition which actually occurs, but we have to only consider these 5 conditions. Okay, now? But still, if you further want to consider, we will say that when the object moves further towards the lens, image form at what? Beyond C. That means beyond twice of f1. Still, it is further away from the lens. You may think that since it is towards the lens, no, it is not towards the lens, because lens can form the image in both the sides, right? So if you consider the object here, it is actually forming here. That is not, it is not near to the what, or not towards the lens. It is again away from the lens. Okay, when you have to measure the object image distance, you have to measure in this direction, right now, in this direction, not towards in this direction. Okay, so again in this case the image is really forming away from the lens, not towards the lens. So which is going to be our answer? Our answer is going to be what? Away from the lens. Right now, this is the proper reason of that question. So those students who actually given me the answer away from the lens, I am going to give them as the, or announce them as the winner. So I'm gonna announce the winner's name. The first answer was given by Sejal. Okay, Sejal give the correct answer. Then after that, Nikita Daga give the correct answer. Then Kohli Oliman give the correct answer. After that, Harshita Jain. Then Hirakjuti Haloe. After that, Ankur. Okay. After that, Diksha Daga give the correct answer. Then Tritesh Pritam give the correct answer. After that, Kaushika Ghosh give the correct answer. Then Ankit Gupta give the correct answer. Okay, 2 students have actually mistaken it. They have actually considered that first away, then towards the lens. So they may thought that since here image is actually from the left side direction, it is maybe moving towards the lens. No, not actually, because when the actually image formed as the partial and erect image, it is going to be in a different category. Okay, in a partial image category, not in that real and inverted category. Okay, when the image is actually forming in the partial category, you have to consider that in this direction. That means it is again moving away from the what? Lenses. So the main answer will be what? The image will form, or when the image is actually formed, image will be shift away from the lens. Okay, this is going to be the correct answer. Again, this is my today's quiz question, depending on this video. Okay, when light enters a glass prism from air, the angle of deviation is least for, okay, 4 options are actually given: blue light, yellow light, violet light, and red light. First watch the video, then give me the answer with proper reason. Okay, so this is my today's quiz competition question. So this is the it, or this is the end of this class. We'll meet you in the next part of the video. Bye bye.